where you don't have to worry about any of the shit I'm about to tell you. But I tell you this first because most people do it this way. I love you guys so much. There's a limit to me, right? That's where Jeff ends, right there. Jeff ends there. You with me? Yeah, I love you. I love doing this, because you're on. All right. There's a limit to me. Then there's a boundary that you better not be in unless I know you really, really well. You with me? Or some people are not really socially with it. They'll turn around and they're like, Mr. Waller, bullshit. But there's a boundary to me. You with me? We all have that. Step off, right? Get out my grill, whatever the shit. So these classes have the same thing. There's the limits. Those are the limits. And then they have boundaries. And you go down by a half, up by a half. So what would this go to? Do you see how now they're going to overlap? There's not going to be any gap. Okay. That's why they did that. So what's the other way to do these classes? These are classes, is to say not 14 to 19, to say this. Like right now, where does 20 go? 20-year-old would go in which class? The second one. And watch, this is still the same thing. Can you guys see how this is still the same thing? Where's the 20-year-old? Still here because that's strictly less than. It's not equal to. Some people give up on this immediately because you're like, I want to leave as much of my algebra behind as I can. And it makes a little tear comes out of sadness this time. Right? But this is beautiful because my scale isn't going to look like this weird shit. It's just going to be 14, 20, 26. Right? So it's up to you which way you do it. But if you do it this way, you must make your scale using the boundaries. So where did it start? 13.5, 19.5, 25.5. Okay. Yes? My scale would look like 14, 20, 26, 32. Nah. So it's up to you which way. I don't care which way you do it. You don't get bonus points if you do it this way. Okay, I like it. So what scale? If I want to make a relative frequency, this is called a histogram. So a bar graph is non-numerical data. Man, woman, Hyundai, BMW, whatever the shit, right? A histogram is numerical scale, numerical data. I like it. So if I want to make a relative frequency histogram, what should my scale be? Do I want to go up to 100%? Hell no. Because then I'm like shoving my picture down really tiny. I want to go up to include what? What's the highest percentage? Yeah. So it depends on what scale I want to use. Maybe I can go up to 35, and then I can use a scale by fives. But it doesn't matter. You can use whatever. You can go up to 32 and make a scale of fours. Right? It's up to you. Maybe. If you have any trouble with scale, we got to get this figured out. Don't make your scale 8, 14, 20, 20. No, it's got to be consistent, or else your picture is going to be a lie, right? The cake is a lie. So it's your 5, 10, 15, 20, 25, 30. I'm not going to make it. Okay, got to take that word out here. All right, 5, 10, 15, 20, 25, 30, 35. Okay, so this is one option. Just make a consistent scale. What's my scale on the x-axis? What's my scale? It's going by what's? 6s, right? Plus 6, plus 6, plus 6. Okay, I like it. Consistent. Okay, kick ass. How tall will the first bar be? How far up do I want to go for the first group? Yeah, like 8.6%, right? So almost 9, not quite 9. So we're doing this by hand, so it doesn't have to be perfect, obviously. Is that cool? And then the rest of them go the same way. So it's I know this is kind of new a little bit, but this has definitely got elements of old stuff in it. It's not a big deal. How tall the bars are represent how much stuff was in that class. So it's a beautiful, quick visual for somebody to see how the data was distributed. The next bar goes up to 20. That's nice. And then I go up to 31. Where's 30? There it is. And then I go up to 25. Shoot. And then 14. All right. Let me ask you a question, see how many people know. Does that look normally distributed? Anybody know what a normal distribution is? Anybody ever heard of a bell curve? Yeah, the bell curve? Supposedly grades are supposed to follow this. So if you ever heard a teacher say they're going to curve the grades, that means they pick the curve up and move it. Right? So if like the highest grade was a 40, maybe, and then here's somebody got a 10, they pick the whole damn thing up, and now the 40 is 100, and now the 10 is a 70 or whatever. You with me? So that's curving. That would be an extreme curve. That's a graduate school curve. My first test in graduate school, I got a 21 out of 40, and I thought, I'm in the wrong place. And the teacher said, good job, Jeff. I'm like, okay. So, you know, the average is like a 23 or something. I'm like, all right. So, where am I at? Da-da-da. Oh, so the only thing left is to put on ages of people at a bus stop. There you go. So you need your, how many S's are there? You need your labels. You need your scales. You got this. It does look roughly normal. It looks like a bell curve a little bit, right? Very roughly normal. Why do we call it normal? Because heights, for example, are normally distributed. Heights of people, heights of men, women, they're normally distributed. You expect most people to be in the middle. And if you see somebody at the ends for height, somebody here, somebody hitting the ceiling, you'll do a double take because it's not normal. It's not usual. It's not something you expect. That's why I use the word normal. Okay, I like it. I like it. So, last thing we're going to do is this, but we're going to talk about how to create these. So everybody got what they want from this year? Okay. So we're just going to do one more thing, I think, because I do want to kind of let us out a little early. We're going to do that field trip. Don't get too excited. So now watch. Yeah, let's do this nice. Okay. So get those written down. There's some data for us. These are grades on a 50-point quiz. Sure. In a class that happened in my imagination. By the way, normally in class I'll make data up on the fly. It's obviously not real, not connected to anything, but on a test or a quiz I like to take stuff from the Census Bureau or from polls done or something. That's real data. First little thing I want to do before we get into how to create those classes, the 14 to 19, those classes, is I want to sort the data very quickly using what's called a stem and leaf plot. Now the book, unfortunately, likes to make things boring and they call it a stem plot. It's a stem and leaf plot. So now watch this. What's kind of repeated up there? There's no real, I don't think I repeated any numbers, but what's repeated? Because there are people that are in their 20s, 30s, 40s, and teens, right? So what's repeated is the first digit. So that's the stems. Oh, yeah. My stems. So there's a stem 1, 2, 3, 4. And the leaves are all the digits that come off those stems. So it's very, it's like biology. So what comes off of 1, what's the first thing? 6, 7, 8. Is that cool? 6, 7, 8. So what's this mean? 17. Then off to 20, let's see if we can put it in order. We got 22, 25, right? 26, 27, 28, 29. That's all of them. Are you with me? Now, of course, we will, the calculator costs enough money. One of the most basic things it can do is put stuff in order for me. So we are going to use the calculator next time to sort stuff. But this is a small set of data we can handle this. 30s are 4 and 5, right? And 40s, there's 1. All right, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's a little good check to do because it sucks when you leave one out. This is not complete until you give me a key. And the key could be just simply 1, 6 equals 16. Let me see if you guys get this next thing. You guys see that? I need that so I know how to read this. Because if my data had instead been 1.7, 2.5, 1.8, this would have looked exactly the same. My key would have been that, put a point in it, right? Okay, so let me take the points away. Go. Do you guys see what I'm saying? The key tells me how to read this whole thing. Just put 1 down. I always get somebody to put every single one of them. That sort of defeats the purpose, right? Okay, maybe. Okay, now. My goal is to get this from that data. How far do I have to cover? What's the lowest and the highest data points? 16 and 41, right? And I'll tell you this, classes, you have to use 5 to 10 of these bad boys, right? 4 is not enough, 11 is too much. In fact, normally for us, we're going to have small enough samples, we're going to use 5, 6, or maybe 7. The larger the sample you use, the more classes you want to use. Does that kind of make sense? There's actually an equation that involves logarithms to figure out, but we're not going to use it. We're just going to use some subjective judgment, right? This is a very small set of data. So I'm going to use 5 classes. So let's say that, so how far do I have to go? My classes have to cover how big of a range? 41 minus 16, right? So I got to go 25. I got to cover that much. This is nice. If I want to use 5 classes and they have to all go across a 25, how big should each class be? 5, right? If every step you take is 5 feet big, right? Number one is how freaking tall are you? And you got to go 25 feet. Won't you take 5 steps? That's basically the physical idea we're using. So how wide, what will the width of my classes be? They will be the range divided by the number of classes. So just like that one I made earlier, had a width of 6. Do you guys remember that? The classes were a width of 6. Now we're going to have a width of 5 for this one. Yes?
Where did you get 5 again from?
Oh, that's just given to us. That is the law. That's the rule. Use at least 5 classes and at most 10. We're never going to use 10 basically because we're not going to get, that's if your sample was in the hundreds of data points. Thankfully, I'm not going to give you, 180 data points to look at. So, what would our classes look like? Let's just stop here once we get these set up. I start at 16. If my classes are 5 wide, where should the next class start? 21, right? You guys see that? Is there any question about that? This can't be 21 though, because then where would 21 go? That was neat. I was like a poem. Do you guys see that? So what's that got to be? 20. And then somebody says, well, then that's 4, Jeff. And then I remind them this is really 15.5 up to 20.5. That's 5. So this book method hides the width this way, but you can see it this way. You guys see that? So I normally put the first data point, add the width, that's one less, then you just keep adding 5. Add 5, add 5, add 5, add 5. I think they get it, Jeff. I know. Where am I at? Add 5. And then this one, now look, here's one. That normally would be 40, right? But my last data point is 41. This is the one time you're allowed to make the last class a little bigger. You suck that 41 in. Suck them on in there. That was really weird to say, I don't care. Right? It just takes that last data point in. And then I could do all the stuff we just did earlier, right? So how many are between 16 and 20, for example?
3.
Yeah, let's go here, Jeff. 1, 2, 3. Right? So you would put a 3 for the frequency. How many are from 21 to 25? 2. You guys see that? And so forth. So then everything we already did just kind of takes over. What we didn't know earlier was how the hell to set those up. I just gave them to you earlier. Okay, so obviously we're going to do more with that. On next Tuesday, I'll have a whole sheet that kind of reviews all of 1 up through histograms. Right now, what I want you to do, please, dear God, get all your stuff together. I can't lock the doors. We're just going to go by my office, and then we're going to go to the tech mall and see the 2 tutoring centers. Do this for me. Go out the door and go unbelievably slowly in that direction so I can catch up to you and get in front of you. You with me? Don't worry about those yet.